Okay, so let's get started. We're going to be taking a look at understanding how to calibrate and tune speed density tables on an F150 application. So we've had tutorials taking a look on a Mustang application that has a mass airflow sensor, how to dial the speed density tables, which are primarily going to be a map pressure-based style system. Now, the way that the Ford Mustang calls on the speed density is going to be different than the way a Ford F-150 calls on the speed density tables. So we'll find on a Mustang, we have a mass airflow sensor, and then we can calculate a map pressure reading, which is fed into speed density tables, which are used for transient fueling, among other things within that Mustang engine control module programming. Ford has changed things a little bit different for the F-150. They do not have a mass airflow sensor. They have a map pressure sensor, so we're directly measuring the manifold pressure. What this allows us to do is actually calculate the amount of air mass entering our engine, but doing it in a different manner. Now, Ford works off of throttle mass flow. So if we know the inlet pressure coming into our throttle body, we know the effective area or the surface area of our throttle blade, we know how much the throttle blade is opening, and we know what the manifold pressure is going to be in our intake plenum, measured from the map pressure sensor, we can actually calculate what the air mass is entering the motor. Now, in a Mustang, things are a little bit different. We know what the air mass is coming into the engine from a mass airflow sensor. We know the throttle blade inlet pressure is going to be baro pressure. We don't know the manifold pressure, but we do know the effective area of the throttle blade and the throttle angle opening. So then we can calculate the map pressure. So things are different. We're calculating the map pressure and feeding it into the speed density with a Mustang. With an F-150, we are going to be using the known inlet pressure, the outlet pressure that's going to be in the manifold, effective area, throttle angle, and that allows us to calculate air mass. So we are essentially inferring the air mass entering the engine. The speed density tables allow us to do that and the conversion and infer the air mass. So when we're looking at an F-150 and our fuel trims are off, let's say 10, 15%, we don't have a mass airflow sensor to go in and edit and to calibrate. What we're going to do is move into the speed density tables and actually edit those directly in order to get our fuel trims right. Now, if you have a stock F-150 with basic bolt-on mods, let's say you add an intake, header, exhaust, speed density tables typically don't need to be touched. They're usually fairly accurate. However, if you're doing force induction or you're doing cams or you're changing the intake manifold, you're changing the breathing of the engine, which will affect and disrupt the speed density tables and require them to have a recalibration done. So if we're in a situation where our fuel trims are out because we performed extensive modifications on an F-150, we need to use the speed density tables to recalibrate and get our fuel trims back in line. Let's take a look at a few things here in a stock F-150 calibration file. We'll talk about using our VCM scanner to do the tuning process. It's pretty straightforward working with all this. Luckily, HP Tuners has provided us a speed density calculator, which is going to be greatly simplifying the calibrating and tuning of our individual speed density tables. Previous to the calculator being available in the HP Tuner software, we would have to go in and edit the slope, which is one of the speed density terms within the speed density model with an F-150. So it works. It's definitely, there's nothing wrong with that method, but the speed density calculator is my preferred way to calibrate and tune an F-150 once we need to dial in our fuel trims better because we've changed the mods on our engine. All right, let's open up a stock equivalent F-150 file here to begin. We're going to go up here to File, then Open, and we're going to move in here to our Training Course folder, so HPT Gen 3 Coyote, and we're going to move into our Sample Calibration File subfolder, and then we're going to grab 2018 F-150 stock. Now, I have other F-150 files in here. I think there might be one or two other files. I believe there is a Whipple file. There might also be a Roush file located in here. I'd have to go down the list, but we have the stock file to reference. Obviously, if you're dealing with an F-150, you've read the file out and you can take a look at that as well. So let's open up this stock file. Now, if we move in here to our engine tab, and then we go over here into our airflow tab, and then into speed density, we're going to find the tables responsible for that speed density calculation. So turning a map pressure reading in the throttle mass flow orientation into an estimation of air mass coming into our engine so that we can calculate the correct loads, we can calculate the correct fueling to the engine. So what we find is that we have offset, quadratic, and slope. These three at a given map point will combine to calculate the air mass coming into our engine and to drive the fueling to the engine and the spark timing to the engine and anything else associated to air mass registration. We also have another additional term that could be turned on, which is our blow-through slope. We'll find that this is always turned off in Mustang and F-150 Coyote applications. This is turned on when you're talking about EcoBoost. This is used to dial in the speed density a little bit further when we're working at elevation with a turbocharger installed. So I'd recommend to leave this off and keeping the logic simple, because this is the way that Ford has intended the F-150 to run in its naturally aspirated state. Even if you're adding force induction, I would still recommend just leave the blow-through slope off. So what we're worried about here is dialing in the offset, quadratic, and slope terms. If we open up these individual tables, let's say for a given map point, let's say we're operating at map point 4 here. So for example, the offset would be engine speed versus a value here, and depending on the units you select, you can change this up here, PSI, KPA. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.